In this video, we are going to go over alkynes. So alkynes are unsaturated hydrocarbons that contain one or more carbon-carbon triple bonds. So carbon-carbon triple bonds are denoted by three parallel lines between two carbon atoms. Carbon atoms of triple bonds have a linear molecular geometry, and so they have bond angles of 180 degrees. The poison dart frog has a shape similar or has the histrionocotoxin molecule, as you can see here, which has two alkyne functional groups in it. And it has a shape similar to the neurotransmitter acetylcholine, which accounts for its paralytical effects. But generally, however, alkynes are not really found in nature. To draw an alkyne structure, skeletal line structures for triple bond is three parallel lines and no zigzag. The condensed structure can show triple bond or imply it. So we have the skeletal line structure. We have our 1, 2, 3. We have our carbon-carbon triple bond here. You see there's no zigzag. It's parallel because the bond angles in a carbon triple bond are 180 degrees, and then the rest of the molecule. In a condensed structure, it's either two carbons right together because there's no hydrogens off of it, or you can write the three parallel lines together. These are the first six alkynes. You can see they have the triple bond between them. We have ethyne, propyne, butyne, pentyne, hexyne. So to name an alkyne, they are based on the number of carbon atoms in the chain with the carbon-carbon triple bond, and the name is according to the proper Latin name with those prefixes that we have used for alkanes and alkenes, and the ending of "-ine". So for an alkyne, they end in "-ine". There's a locator number used to indicate the first carbon of the carbon-carbon triple bond when there is more than three carbons in the chain, and you number from the end of the carbon chain closest to the triple bond. So we see here that we have four carbon chain, 1, 2, 3, 4, and we have our carbon-carbon triple bond at carbon 1. So we have a 1 butyne, we have a methyl group at 3, so we have 3 methyl, 1 butyne. In this structure on the right, we have a 7 carbon chain, which is hept. Ine means there's a triple bond. And our triple bond starts at carbon 3. So we have a 3 heptyne. We also have 2 methyl groups on carbon 6. So it's 6,6 dimethyl 3 heptyne. So to practice, we're going to write the skeletal line structure for 3-octyne and write IUPAC names for the alkynes below. So pause the video, and then when you're ready, come back and we'll do it together. So to write the skeletal structure for 3-octyne, we want to do, usually what we do is we do our zigzag structure, but remember when we have our triple bond, it is parallel and it has the 180 degrees. So for 3-octyne, it's going to start on the third carbon. So I'm going to do carbon 1, 2, 3. So this is 1, 2, 3. And it's going to start my triple bond. And this is going to be carbon 4. And then it's going to go to 5, 6, 7, 8. 5, 6, 7, 8. So this shows me that there's a triple bond of 3 and there's an 8 chain. For the IUPAC name for the following, we're going to number it. We have 1, 2, 3, 4, 5, 6. Hex equals 6. Our triple bond starts at carbon 3, so it'd be 3 hex 9. Over here, we have 1, 2, three, four, five, six. Again, hex equals six. Now we've numbered it from left to right, and our triple bond starts at carbon four. If we number it right to left, be one, two, three, four, five, six. If we number it left to right, our carbon triple bond starts at carbon two because we're looking at it from the right to the left. So this method, numbering it from right to left, makes our locator number the smallest. Instead of four, it's a two. So this is two hexyne. So in summary, alkynes contain one or more carbon-carbon triple bonds drawn as three parallel lines in the skeletal line structure. Alkynes are named according to IUPAC rules for alkanes, except the ending is changed to "-ine", and a locator number is added at the beginning of the name to indicate the first carbon in the chain that contains the carbon-carbon triple bond. And the chain is numbered from the end closest to the triple bond.